Hi, everyone. Thank you for attending today's webinar, Solar Design in the Third Dimension, All-Terrain Trackers, Cut Fill, Piles, and Shading. I'm Kelly Pickerel, editor of Solar Power World, and before we get started, I want to go over just a few housekeeping items. You can view the slides for today's presentation in the resource window on your screen, and you can submit any questions related to today's webinar in the Q&A window. If we do not get to your question, our presenters may reach out to you afterwards. Finally, if you are watching this webinar on demand, you can still use all of these features, including submitting questions to our presenters. So let's get started with today's webinar on 3D site strategy evaluation. I'd like to thank PVFARM for sponsoring this presentation. Today, we will hear from Benjamin Callum, head of product, and Maxim Markovich, head of technology, both with PVFARM, about tracker selection and large-scale projects. So now I will turn things over to Ben to get us started.
All right, thank you. And thanks to everybody for joining today. So today we're going to talk about solar design in the third dimension. And by third dimension, in this case, we're talking about the elevation or the Z. That'll come up a lot, so hopefully there's no confusions and people aren't in a different dimension altogether here as we get going. So first, to level set, solar is not a 2D discipline. That should go without saying. And while it'd be pretty strange to have any flat earthers on a solar webinar, this is not actually a dig at 2D representation. 2D is, as the most common way of representing a solar layout, and for good reason. First of all, paper, basically, but 2D also tells us a heck of a lot about our project. It's just that it only goes so deep. But before we get into that, what we may be missing, let's talk about how we got here. The industry landscape is much different than it was even a handful of years ago. Sites used to be far smaller. The average utility scale project has grown almost 500%, according to some metrics, over the last decade, and land strategies are now far, far more complex. So not only are the projects larger, they're using fragmented land strategies on much rougher terrain. They look more like this site that you see on the screen here, a scattering of buildable areas, all different sizes, shapes, and strewn about complex terrain. A decade into serious renewable investment, most of the prime real estate is gone, and that leaves us with kind of the scraps here, stitching these different elements together. Lastly, we didn't have this technology we have today. That's also kind of a big piece. 3D used to be pretty hard. Evaluating things in 3D was complicated. It required special hardware, modeling skills, lots of time and detail that went into that. And today there's a lot more opportunities out on the market. So now that the third dimension is back in the picture and a critical part of our projects, what can we do about it? Lots of crazy things happen in the world of capital project development that are hard to predict. We call those the unknown unknowns, the things we didn't know we were missing in the first place. That's the kind of crazy stuff that happens on site or in the design process that you didn't expect. Good news is that elevation, or the third dimension, is a known unknown. It's something we are aware of, but we often don't take the time or have the know-how to understand the implications of. And the other good news is that by underserving this critical aspect of the project development, it means there's quite often literal money left on the table. With a tool like PVFARM, you can begin to quantify the impacts and build your project strategy around it, which means there's a lot of opportunity. Before we get into the how, let's talk about the why. Otherwise, our balance sheet. In the simplified version of a typical pro forma, we can see that a large portion of our profit is tied up in, or at least related to, the third dimension. We're not sure yet if a tool like ours can help with your debt or tax obligations, but it sure can help improve the other aspects, which all have a direct bearing on the profit of the project. So let's look first at capital costs. First, these are industry average distributions, just to get that on the table, and that your specific costs might be slightly different depending on your business model, but the relative relationships will be more or less the same. So going clockwise, we have things you need to buy, followed by the things you need to do, and then pass the regulatory requirements, and what you're left with at the end of the day is the overhead, which is hopefully low, and your margin if this is your business. To repeat, the things you buy affect the things you do, including the regulatory requirements, and eat into your overhead and margin. There's an obvious sort of knock-on effect here where decisions made upstream affect those downstream and can very quickly burn holes in your pockets if you're not careful. This is one big complex system where all the choices are interconnected. So which kind of pieces of this pie are directly and primarily concerned with the third dimension? Well, unfortunately, or maybe fortunately for us, pretty much all of them. I did have a conversation a few months ago where someone was arguing that it wasn't appropriate to include modules when talking about 3D, but as you can see, sort of module is just as tied as anything else to the structural and civil sort of aspects of the project. It's usually one of the first decisions that actually gets made in this process. These flow down into electrical systems. They certainly affect labor. If you've ever tried to watch a team install panels on trackers that are more than 7 or 8 feet off the ground, it's a little bit difficult, and that results in more complexity and leads to logistical challenges, and all these have cost implications. So that was CapEx, but what about our revenue, right? So this is more simple from a math standpoint. If we just remember that we can reduce the LCOE number on the left by driving up the production, right? This is an amazing thing actually, because it as long as we take the life cycle perspective, which is something that is really inherent to our industry, we can consider relatively small cost increases that boost production disproportionately. Or maybe we take a small hit on performance to offset a large reduction in CapEx, or vice versa. Or even if we're really lucky, we can drive down the cost and up production. So there's an incredible flexibility here because we can play with both the cost and the production, and that allows us to tune this, and it really opens up the world of possibilities here. But like all things, we have to start somewhere, and often, especially for those that aren't kind of grizzled industry vets, is where to start, right? What dials do I turn, and how do I know I'm not turning them too far? That's a big question, and we hear that all the time. So to answer this, you will need to be able to ask the right questions and receive reliable answers. So there's a lot, there's some questions on the side here, but I'll focus really in the center of this. This is a diagram we use to illustrate which areas of design have strong relationships to the other. The darker the line, the more the influence, and as you probably guessed, most of these also have 3D implications. The array system is obviously related to the civil. The land strategy is going to impact both of those. And electrical sort of ties everything together. It's also worth noting here that we're here representing PVFARM. It's also worth noting that this is also pretty much an architectural diagram of PVFARM, our software. The platform was really designed so that engineers could ask these questions and be confident in the answers that they receive, and sort of understand all the different angles. You may also be familiar with the capability maturity model. And if not, this is really just sort of the stair steps to maturity. And we like to use this to compare the transition from 2D to 3D in this context. If you've dealt with other sort of areas of the building industry, they've sort of gone through this progression as well. As people, projects, and organizations proceed kind of left to right here, there are characteristics of each step that eventually lead to strategic implementation. And by our measure, sort of thinking about this over several or many months, we think it's difficult, if not entirely impossible, to get to strategic implementation as an organization without considering 3D. You have to do it, and you probably have to do it several steps earlier. So with that, I'll turn it over to Maxime to dig in deeper with some examples of how this plays out in practice. Over to you, Max.
Thank you, man. So yeah, let's talk specifically about, and we will start with a tracker selection, and let's talk about what insights we can get from a third dimension perspective on the tracker selection process. So if I will go to the next slide, basically finding the optimal tracker sites, right? So this is the task which most people think that choosing it and choosing the right tracker size is purely a 2D exercise, which is fair. This is how it's done today. People draw plans and see which rectangles fit better based on their goals and priorities. They see which combinations of rectangles fit better, etc. But there are definitely some things some insights that third dimension can give us. And those might be a good addition towards making the best decision about the tracker size choice. Okay, so we will start with a simple and small fragment of our bigger site. We will stick to a certain specific grading strategy. It doesn't matter which one, because it's going to be consistent across all of our examples. And our base case is 78 more trackers. Basically, we place them on the terrain within the limitations they have. And as a result, we got 76,600 cubic yards cut and then 68,500 cubic yards fill, which is around $500,000 cost of the grading for those trackers. So the whole question here is that, okay, what if we will choose a different tracker size? How will it affect our grading, and like how much more expensive or less expensive it's going to be? To answer this question, we run another two analyses. Basically, we use 96 mod trackers and we use 66 mod trackers. Basically, we achieved almost the same DC for both sides, but if you will have a look, you basically will notice that using a longer tracker is expensive for this particular parcel. It's expensive, it's a lot more expensive. So it's like 35% more than using 78 trackers, and then using 66 more trackers is like 11.5% less expensive. It doesn't actually mean that we should always go for shorter trackers and all this stuff. Obviously, the sites are very specific, and there are many contextual things which will be the major when making decisions. But this is just having this good addition of third dimension. It's like an extra layer addition of wisdom, which can help us, to actually find the actionable insight. So imagine thinking about it at the very beginning of the project. Depends on how challenging the terrain is or how easy it is. Okay, so let's go further, and then let's jump into finding the optimal tracker mix for the whole site. So it's a very exciting exercise, which requires a whole bunch of scenarios to be considered. And usually people upstream, they don't have time to do that at very early phase of the project, and then people cannot do it downstream as well, because the decisions have been already made, and it's going to be kind of will require many considerations. So basically here for this particular site, as you can see, we have multiple parcels, and we thought, okay, let's run a couple of different analyses. So we could use like 78 mods trackers for the whole site, and then 96 mods trackers for the whole site, or we could mix trackers. For example, in the center of the slide, and here you can see that we could actually use 66 mod trackers for some parts of the site, and then we could use 96 mod trackers for others. And then a little bit different situation from the right, we just basically use different parcels for different modules. The whole point was to achieve the same amount of DC and to run those analyses in order to find the best possible solution for us in that particular situation. So basically, as I said, this is quite many computations. Quite many computations needs to be done, but this can be pay off significantly. So let's go to the next slide. So we run 4 scenarios, and then which I already explained, and basically, again, just to emphasize, same grading strategy, almost the same DC, and certainly the same terrain. So look what we've got. So we've got completely different results. So they are illustrated on the slide, which you can see right now. Surprisingly, 96 mod tracker was not the most expensive option. In example 3, in the column number 3, you can see that when we randomly chose areas for 66 mode trackers, which is basically blue ones, that was very surprising, and basically apparently it didn't work out. This is the most expensive option. So initially when we ran this, we thought, okay, we will use shorter trackers where we have steeper slopes, and then we use longer trackers for a more flattened parts of the site. But that doesn't work that way basically, and there is no one fits all size advice. And usually the best way to understand what's going on and what configuration is the best is to actually run a bunch of options and to see the chart and to see what do we get. So what's important to mention within this specific example is that the best option is 23% better than the worst one. 23% by doing just simply analysis and by just running a bunch of options. And for basically in absolute numbers, this is 360,000 cubic yards. So basically, I think when people choose trackers, it is important to consider not only DC and the configuration of the blocks and some architectures of the layout, but it is also worth spending some time in understanding what's the best strategy from a grading standpoint, from a cut fill standpoint. And obviously taking this into account together with all our usual old considerations plus logistics, this might be the best combination to actually find the best size of the tracker. So now let's go to the next topic, which is a trendy one, trendy topic of the last years. Rigid versus terrain following trackers. Some people call terrain following trackers with undulated capabilities. Some people call them all terrain, basically, but this is, the meaning is the same. These are trackers that can follow terrain. In other words, that can basically change their slope from bay to bay. And the bay is basically the distance between two piles. So let's basically go to the next slide and discuss a bit, again, for those who are not aware, like what's actually terrain following trackers. As I said, so from the left, you can see a rigid tracker example. So the only limitation for this tracker that it has a specific maximum allowable slope. So let's say if it's a 10%, so then the tracker cannot be installed on the terrain with the slope more than 10%. If it's a 15, same story. So terrain following tracker is more complicated, and you can see it from the right. So this tracker has also limitations, but those limitations like 10% or 15% depends on manufacturer. They are applied to each bay. And also another limitation is that the slope bay-to-bay slope change, basically the slope change on top of each pile shouldn't be more than a certain number. Let's again, I will just take an industry average number like 1.5%. So basically, if you have the first bay 10% and so the second one 11.5, you're all good. But if you have the first one 10 and then the second one 15, it's not okay. It's not working. So, and then some manufacturers, they also have limitations about cumulative slope change, meaning that if you have a motor, let's say in the middle of your tracker, and then so the cumulative, which is total slope change on top of each pile, shouldn't be more than a certain number. Let's say, again, to give you industry standard, 7% or 6%, something like that. So that's basically the main difference. From a cost standpoint, they're also different. There are different manufacturers, there are different numbers. They might be 10, 20%. The terrain following trackers might be more expensive, but obviously it depends on your area, on manufacturer, on your conditions, wind conditions, and many other things. So why is that so trendy today? As Ben mentioned before, we basically don't have any more a good sites. We have fancy terrains, and we have quite difficult terrains, and basically the terrain following trackers can save you the cut and fill, can save you the amount of dirt you need to move in order to make this installable on the site. Okay, so on this particular example, again, our project, which we chosen for this specific webinar, is around 580 megawatts DC project. on a very challenging terrain. So don't be scared of numbers. This terrain is pretty crazy. So we basically used rigid trackers on the left option, and then the terrain following trackers on the right. So we were able to save 35% in cut and fill, which is in absolute numbers 2.2 millions of cubic yards, just simply by using basically undulated trackers with undulated capabilities. So and usually like basically and we didn't stick to the most aggressive terrain following trackers, and basically this is the way how those trackers are being evaluated in the most cases, and you know that they cost more, and then you save some money on the grading, and so you make a it might seem easy calculations, but those two numbers, you need to get them. And then, so this is where you can get and where you can make a decision about what to go for, rigid trackers or terrain following trackers. Okay, so let's go to the next one. So we talked about trackers, and just to summarize before we go into the next chapter, is that first of all, third dimension can give insights about about grading for a specific lens or specific module number per tracker, and can help to choose the best option, the best size. And also the second one, there is no way to evaluate rigid versus terrain following trackers without actually working on the terrain. So let's go to the next chapter, which is civil and pile optimization opportunities. So it's time to get our feet wet. Let's connect the dots for our rock trio that occupies quite a large part of the capital cost Ben was talking about a couple of minutes ago. And this is cut fill, this is piles, and this is trackers. So those rock band members, they work together. They are all interconnected. So let's imagine this situation. We have those three triangles, and basically edge length is a volume or quantity, or maybe some metric, and then edge thickness is a rate per volume or per quantity, and then basically the cost is edge length multiplied by edge thickness. So as I said, all those components interconnected. What does it mean? So let's say we want to save. We want to avoid as much as possible cut and fill. We always can do this by increasing the gradient window, but increasing gradient window will give us longer piles. Longer piles will push us to buy more steel. So steel is expensive. So basically by trying to avoid cut and fill, we increase our cost for the piles. So, and basically the whole challenge here is to find a right balance between those. And there are a bunch of analogies people can use here, balloons, mattresses, and stuff like that. But I like triangles because it shows very precisely how those things are connected. For example, another example, if we will have a look at the central one or the last one, basically trackers rigidity is a strange word here, but basically what I'm trying to say is that if you use a rigid trackers, you have a certain limitations with your piles and cut fill already. So if you use a rigid trackers and 10% and 96 modules, that's already a serious limitation. So if you have a terrain following trackers, which is you have less rigidity, you will basically be able to be more flexible with piles and cut fill. And let's say if we want to make cut fill 0, crazy situation, hypothetical, I mean, it's not a problem. We will need to have a very long piles, which might not be a problem for your situation, but also very long piles will probably create some problems with structural calculations for the trackers, meaning that they might increase the wind load. So we will again need to have a bigger cross sections. We will probably need to have more expensive tracker frames, torque tubes, and stuff like that. So basically all those components are connected, and this is a very, very exciting but still beautiful and challenging and beautiful balancing act. So yeah, let's go and see what we can do here. So what did we do? We grabbed the base case again, rigid trackers, half feet gradient window, zero net balance grading strategy, meaning that we wanted to have same amount cut and fill. And we got some numbers. We got quantities, we got some rates, benchmarks from the market. And so we get the cost for our base case. So after that, we wanted, and the cost was around like 110 million for this particular project, which is a total cost. So then we wanted to test a bunch of different strategies. So we wanted to test 6 different scenarios with different grading window, half feet, 1 feet, 1.5 feet, and different trackers. So the first 3 options with rigid trackers, and so the second 3 options with the terrain following trackers. Basically, it took us not that much, not that long. It's around 10-15 minutes to run through all of those options. Just before we go and talk about results, I just want to explain a bit what does it mean to actually run the grading analysis for basically terrain. On the picture from the left of the slide, you can see it's a bit of a drama case, obviously, but it shows very good what it means. So you have an existing terrain, and so then you have a tracker, and so the tracker has its own limitations. Let's say it's 10% slope limitation, and it's a rigid tracker, and so there is only this limited amount of options you have how to place this tracker. And let's say if you already know that you cannot change your layout and you just want this layout to be landed on the terrain, so basically you can actually start rotating this tracker in order to find the most efficient position of the tracker. And what it means, the most efficient position, basically means that position where you do the least possible amount, you move the least possible amount of dirt. So that's the whole point of doing cut fill. So let's dive into our results and let's talk about those scenarios. So after reviewing those scenarios, we came to conclusion that the most efficient option is with half feet grading window and trackers following terrain. The problem here is that there was no way to actually to say what was better before we run those simulations. It's like, you can see, okay, it's a slopey side, so let's go for undulated trackers with undulated capabilities. That's not always works, and basically there is no, as I said before, all side feed solution or advice for this. But basically the only way is to to actually do the legwork. And luckily for all of us, servers that do computations, they don't need to rest. And so we can run as many options as we need, as long as we come up with ideas what are those options should be. So the main takeaway here is that the worst option costs 5 million more than the best one. So it's worth it to run 100 calculations to spot such benefits, right? So it's 5% from the total cost of the civil piles and trackers, but I mean 5 millions. And this insight can be acquired only in the third dimension. There is no way to understand it into 2D. Terrain is a specific object, and basically historical benchmarks won't work in this situation. So yeah, let's move on. And just a couple more notes before we go to the next topic. So basically, just to share a bunch of other insights without numbers that can be obtained from a third dimension. Everything we talked before were quite a low-hanging fruits. So it was quite straightforward that we needed to run those options to find the best balance or the best trade-off to make. But there is an opportunity to collect more insights, or it's better to say more efficiency, by doing drill-down optimization. So in PVFARM, we support the flow where you can run initial analysis, let's say with half feet grading window, as you can see here, right? Just draw it as you can see here. So initial analysis, half feet. Then you can define the areas where the biggest amount, cut and fill, and then you can apply a different grading window for those areas. I'm not sure whether the construction folks will thank you for that, but you might definitely find your efficiency. And as our super users say, talking about PVFARM is that they won't have opportunity to test even the worst their ideas. So this might be a good one. Again, depends on your site, depends on the context, depends on the situation. So combining this approach with different tracker strategy, with different grading strategy, with different constraints for different parcels of site will definitely gives us not 100, but a couple of hundreds of different options to run in order to understand the best trade-offs to make. And this is where we try to build the tool which actually allow our customers to do so. But again, as I said before, hundreds of options is not a problem. We have a very hard-working servers, and yeah, we can do more wondering and have more fun. And the last thing I want to talk about piles, civil, and trackers is that after we did run those rough simulations, it was mentioning that constraints polishing, it might be a separate process where a different grading might be applied to a different areas of the site. I mean, array grading, catch grading, rod grading. So yeah, that's pretty much it about civil versus piles versus trackers. So now let's talk about quite an important aspect which drive our revenue, and it's energy production. So let me give you a couple of examples. So first of all, what we did is that we run energy production on a flat layout. So that's basically what people do today, and I would say people do even more. Mostly like people run shading on the flat layout. And as you see here that because we run a shading on a flat layout, we lost 8.5% of the production, which is again, it doesn't mean that much until you translate it into revenue over lifetime, right? But the next steps is there are not those many who actually consider it's a placing this on the terrain and running energy on that, okay? So let's say if we will go to the next our option, which is our 3D layout shading, which means that we placed all those trackers on the terrain, and we see quite a unique case here. We got almost 1% up of energy. So luckily for us, terrain was turned on and was looking towards the sun, so we got 1% more. But the thing is that the next step would be probably the most important, is that we need to understand how much the terrain shades itself. Because this was quite a challenging terrain. Let me just quickly jump and slide to show you. So we had this terrain, which basically huge slopes in here and then in here, and then it's in general it's quite undulated. So basically, if we go back to our situation here, so we by simply taking terrain shading into account, we lost 2.4%, which is it's around 10 million over 25 years lifetime for this particular project. It's a lot. So not taking this insight from a 3D world might be indeed harmful for revenue projections for our project. And this is precisely why we encourage people to work with the third dimension as early as possible, because it might give a very useful layer of wisdom. So let's go further and talk about a couple of other basically comparisons our tool PVFARM can provide. First of all, let's see how energy production spread across the different blocks, which is another unique perspective that can help to choose inverters wisely or to avoid maybe shaded spots, which is basically, for example, in this particular slide, when we compare two schemes, shading in the 3D and then shading in the 3D plus terrain shading from the right. So we will actually see that the spots that were affected significantly. So for example, if I will just draw this bit and then this bit and then basically this area and even this area, so we can see the blocks that were affected a lot by terrain shading. And let's say if we have let's say enough space and we want to decide, and let's say our terrain is equally bad or equally good everywhere, and we want to decide where we don't want to build our blocks, and we already lock into specific row-to-row space, this approach might give you insight where actually you have the worst blocks from an energy production, and this can give you a good insights as well about the project from the third dimension. Okay, so yeah, that's the energy, and now I just want to hand over back to Ben to summarize all those examples you just heard.
Yeah, thanks, Max. So today we saw some great examples of balancing different criteria across the site. Everything you see here, while we are looking at, there are a number of sort of 2D images to show the product. You'll see the section cuts and things like that, which show everything here is happening fully in 3D. So the last thing we'll leave you with here, as we think about how to break up, as we think about applying those different criteria to the site, is that type of analysis doesn't have to stop at the kind of full site level. In a lot of the cases that we looked at today, we're applying these different criteria maybe to the whole site. As Max said, it's 500 some megawatts. So that one size fits all may not actually work across the entire site. So all the techniques and relationships we talked about, energy to the array systems, the civil, the electrical, all of those things. We actually provide the ability for you to apply those on a field by field basis anywhere on the site. So in other words, there was an earlier example where Maxime took sort of the worst areas from a grading standpoint and applied a different grading strategy to that. So that may be one sort of strategy. You may have different tracker placement that you want to place, which obviously may inform your tracker or your grading strategy down the road. Your energy production, that could be your row-to-row spacing, that could be something related to the grading. We're able to layer these things in sort of as fine a detail as you as the designer bring to the table. So, for example, if my site condition suggests that sort of 80% of the site can be built using my favorite tracker and my favorite grading strategy and the things that make the whole process efficient, you're always going to have that kind of 20% around the edges that you need to go edit and you need to go take care of. And we give you extreme sort of flexibility to be able to go into that. So the same analysis we looked at today, in other words, you can take that into sort of subfield or sub area of the site and apply that same sort of methodology. That's what our sort of Jedi level users do on a regular basis. But we just wanted to highlight that sort of this same approach can be refined really at any scale. So with that, I think we'll turn over to some questions and appreciate everyone's time today.
Awesome. Yes, we're going to get into the Q&A portion of the webinar now. You can submit your questions in the Q&A box on your screen. We have a lot of really good questions already. First question I will ask, what is the maximum grade change you allow in your terrain following trackers inside your software?
Okay, I will take this one. So the maximum grade change is a parameter, which is under control of the user. And usually it comes from a manufacturer. So whatever you will input in there. So any number you will input in there, I think we will support even crazy cases. Yeah, so any number, the answer. Yeah.
Okay. Next question. How do you propose to evaluate the energy output of terrain following trackers? Can PVFARM do that? Because this will be essential when evaluating the overall benefit.
Yeah. Ben, do you mind if I'll take this one?
Yeah, go for it.
Yeah, so basically we built basically it's all about shading, right? So it's all about shading and it's all about how we calculate the shading for terrain following trackers. We built the algorithm that can do it for both At the moment, the shading for the terrain following trackers is not available in the production because we're testing it. I would say that you're right. There are some very good insights about it, and so I think very soon we will be able to push it to the production, so it will be available for all our users.
Okay. How do your cut and fill, energy, and other functions in PVFARM compare to other standards, like maybe PVSYST?
Sure. Max, you want me to take that?
Yeah, go ahead then.
Yeah, so we've done a number of different comparisons with some of our industry partners that we're working with on both of those fronts. I think I'll tackle sort of the energy for, portion of that first. We've done a number of sort of apples to apples comparisons, meaning that the same parameters are used basically between our PVFARM real-time energy model and some of the other standards. And usually we're right at about 5% or less in comparison. Now, that said, there's sort of one big advantage to PVFARM's application, and that is that we do all of this stuff in runtime, meaning that while you're using the software, while you're looking at things in 3D, all those energy calculations are happening as you're at runtime while you're in the software. So you're seeing those updates. If I go in, I delete a tracker, I change the number of strings on that tracker, make any of those modifications, you're going to see those updates real time. Our focus from a product standpoint is not on competing with PVSYST. You can export directly. You can export your shade scenes directly from our software into PVSYST, so you can go check that work. But frankly, from a decision-making standpoint, what we see is that to make really informed decisions from a design perspective, we think we're right there. If you feel differently, please get in touch, and we're happy to sort of talk through that. But we're not really focused on that sort of bankable energy model strategy. We're really about informed design in engineering decision making. On the other one, referring to civil, typically those ranges, they can be a little bit bigger. It can go, say 15 to 25%, I think, is what we typically see from a comparative standpoint. Now, if you're a civil designer, you know this, and you're on the call today, you know that there are very, very different ways of designing civil sites. So PVFARM's grading algorithms work in a specific way. The difference in percentage really seems to come down to the approach in terms of how a designer may or may not approach a particular site and those grading conditions. Everybody sort of has their own style. Last point on that is that when we place trackers, when we do cut and fill grading, we quantify everything again, sort of in runtime in the platform. And you can verify every single pile on every single tracker across the entire site in all of those different grades. And you can see that very, very specifically, and you can see it in 3D. So we feel pretty confident that we're doing what we need to do. We really attribute that difference to stylistic kind of differences.
Perfect answer. Good job. The next question is kind of a two-parter. How is the software available? Is it subscription-based? And then how does the pricing work?
Yeah, so we just launched in January, and we're working with kind of strategic industry folks. So if you're interested in getting involved in interest in our software, please reach out, and a member of our sales team or one of us will get in touch, and we'll talk you through those issues.
Perfect. Someone is wondering, can you change the tracker tolerance and determine the amount of cut fill required according to the slope or elevation tolerance?
Take that, Max?
Okay. Yeah, I'll take this one. Yes, we can change the tracker tolerance, and we can define the net gradient balance for a specific site or for a specific area. So we cannot specify it for every tracker, but we can specify it for a group of trackers or a specific area.
Okay.
Good question.
It's up to you.
Yeah, the answer, short answer.
Do you have any as-built data to understand how close your software has come to actual grading numbers?
Yeah, I'll take this one. That's a very good question, and we basically work on some case studies which we want to publish regarding our software, but how close it is basically defined by whether you are from upstream or from downstream, you know? So we used to get results which were lower than people from EPC firms or like engineering consultancies. And then but at the same time, we got a very good results for developers, but we tweaked this many times and did multiple validations with different folks. And we help people to actually leverage parameters in our software to respect the strategy or the, I would say, grading mentality they have. Because it's like, you can always go with some numbers because we allow you to run grading with like 10, 15 parameters. And basically, based on your mentality, how you want to go aggressively or you want to be like conservative or less conservative, you can get a different grading results. And this is why we focused more on understanding how people work, and then we explained how it is achievable in our software. So we have folks who actually are super satisfied with the numbers, and they're very close to their manual grading.
Perfect. Reminder, you can continue to submit questions in the Q&A box on your screen. We're going to try to get through just a few more. This question says, the presentation, it seems to imply a top-down approach. Is that the only approach you recommend?
I'll take that one. So I think there's a little bit of a sea change and sort of opportunity from that top-down approach as compared to what we've seen kind of historically within the industry, where someone might take sort of a small or localized piece of the site with some kind of typical conditions, and they would kind of build, building blocks and then extrapolate out to the rest of the site. One of the advantages that we have with our automation is that, and sort of this holistic approach, is you really can start even from look at a statistical distribution. Take trackers as an example. You could put every tracker you've ever seen on the market into the software and run layouts on it, and it will give you a distribution of basically how those would fit onto the site. One of the methods that some of our users will use is they'll take that, they'll sort of throw out the trackers to minimize the variability and kind of hone that down. But again, as I said earlier, you're still going to end up often with kind of some work to be done around the edges. So what we typically recommend is sort of a top-down approach. You start with some a general sort of hypothesis about what might work on the site. You test some of these different scenarios, you run some simulations, and as you drill down into that, you're going to say, okay, I've satisfied 85% of the site. Let me go take the remainder. I'm going to break that off into one of those sort of sub areas that we talked about, and I'm going to go test some additional criteria. And usually after a couple layers of that, kind of from the top down, you're going to solve 99.9% of your problems with a very limited set of criteria. What that does is two things. One, it prevents you from having lots of variety sort of scattered across the site. So, one block with like 5 different conditions in it, as an example, you get to avoid that. And it also, it localizes sort of any of these customizations that are inevitable on a big design project. And it also allows you to sort of tune those things. So in certain cases, as Max said earlier, you may have a topography condition that really is maybe more suitable to fixed tilt. So maybe you want to put fixed tilt on one part of the project, because it's west facing or whatever, and the rest of the site you want to be single axis. You can sort of apply those different strategies based on the site conditions, which we think sort of that drill down approach is the right one.
Okay. Okay, our next question. is your software web-based or is it a standalone desktop application?
It's a web-based software, and
Okay.
it's built, yeah, and it's built in a way that we actually manage very heavy computations on our servers, but actually the model itself and the exploring of the model and quantifying and understanding the model is happening with the help of your local machine GPU, which makes us, which helps us to achieve actually amazing efficiency. So our software can be run for the projects up to 1 gigawatt size with full details. I mean, trenches, wiring, cut fill, etc. So good question.
Okay. And then can you input LiDAR data? Can you use, can you import CAD files? What can you import into the program?
Yeah, so I would say that terrain, especially terrain, our customers bring it from the Civil 3D. So we build a specific plugin for Civil 3D. So basically, if you can upload and open your terrain in the Civil 3D, you can import it to PVFARM. We also support LandXML, DEM, and GeoTIFF. That's pretty much it, yeah.
Hey, Max, there was one other part of that question, though, I think, which is about kind of layouts, and I'm looking at the chat here.
That's amazing.
You can, that's a fun one for us. You can actually go draw your layouts in any other sort of CAD application. It can be KMZ, KML, as Max said, CAD formats. And you can bring those into our software. Even if it's like a flat rectangle, you can bring that in and you can convert it into a full 3D asset and do all the things we talked about today. So if you started somewhere else, you can come take advantage of PVFARM, and you can, and then you can go back, we can export back out to those as well. There's a lot of cool stuff on the import side. That's a huge topic that we could do a whole webinar on. But.
Okay, this will be our last question. Is there a trial version available right now of PVFARM?
I'll just I'll refer to what I said earlier. We're not, it's not an open trial, but we're happy to give you a demo and sort of walk through what your needs are. And if you're interested, please get in touch.
Okay, perfect. Well, that is all the time that we have for questions today. If you have additional unanswered questions, please feel free to contact our presenters on your own. And this webinar will be shared with all registrants, so you can view it again at your convenience. So I would like to thank Ben and Maxime for being here, and PVFARM for sponsoring today's webinar. Thank you to everyone for joining us today, and hope to see you at more Solar Power World webinars in the future. Thank you.
Thank you all.
Thank you.